talk about derivatives, but most of the work structure that a derivative is a slope because of the rate of change. If you talk about rates of change, let's say I'm talking about derivatives. So this is what you're going to say. Why do you learn this? Because derivatives give the rates at which things change. So this is where we started with slope of the tangent line. We talked about instantaneous rate of change. We even talked about instantaneous speed or velocity. And this is the derivative definition. Now, obviously, we're not doing the derivative definition anymore, but that's still what we're doing when we find these shortcuts. We're still finding that instantaneous rate of change, the slope of the tangent line. If they say average rate of change, or average speed, or average velocity, right, that's not a derivative. That is just for an interval from A to B. It is f of b minus f of a over b minus a. It's just the slope between those 2 points. Or talking about speed, it's the total distance traveled divided by the total time. And so again, looking for that word average tells you whether or not you're doing derivatives or you're doing so today, all we're So, it says a square of side length x is inscribed in a circle of radius 1. Write the area A of the square as a function of the radius r of the circle. First of all, what does it mean to say that a square is inscribed? The square is inscribed inside. So, I'm going to make a really tiny circle. And then I'm going to make a square inside it. So inscribed means more than just it means more than just inside. It means that every corner of the square is touching the circle. Okay, so it's not just like hanging out inside. It's like every corner here touches the circle. Which means if this was done perfectly, and there's a third circle, then each of these would be like even. We want to write the area of the square as a function of the radius of the circle. What do you got? Any ideas? First of all, what is the area normally of a square? If the side, if this was side length S of the square, what would you say the area is? S squared, right? But we need to write that in terms of the radius. So I could take this and draw it straight down and make the radius, right? But that's not really going to help me much. What if I took it and I connected it over here? Would that be a radius? Okay, now what does this actually stand to say? What kind of triangle have I just made? What's this thing right here? Isn't it? So I've made an isosceles right triangle for shorter. So what are the angles down here going to be? 45, 45, 90 triangle. Oh my gosh, does that bring back some memory from pre-calculus of a 45, 45, 90 triangle? This is R and this is R. What's the side supposed to be? Let's just do Pythagorean theorem since we're not sure, okay? So I'm going to call that S, and let's do Pythagorean theorem. R squared plus R squared would equal that hypotenuse squared. Yes? So 2R squared equals S squared. The square root of that. It would be like the side or the hypotenuse would equal R squared root of 2. Remember the ratio like 1, 1 square root of 2? Where the square root of 2 over 2 comes from. The angle of the hypotenuse. But we could get there. So if we know, think about this, we know that area, we normally say is side squared. I'm going to stop up here. Side squared equals 2R squared. So the area of this square in terms of the radius is 2R. That's why that's like an SAT question. No calculus here. Some of the problems will give you the equation. So look at part B. It says find the instantaneous rate of change of the area with respect to the radius of the circle. So you have to know this vocabulary. What does it mean I'm doing when I find the instantaneous rate of change? The derivative. They're not x's and y's, but think about this is your y and this is your x. So you could say a prime, but I think it's better to write it as like the dy over dx. So I'm going to say dA over dr. The derivative, or the rate of change of the area with respect to the radius of the circle. So dy over dx. And then r is just like your x, so you just take the derivative. So Connor, what's the derivative of 2r squared? 4r. So it says evaluate the rate of change of A at r equals 1 and r equals 8. Yeah, rate of change means derivative. We've got the derivative. So at r equals 1, the rate of change of the area would be 4 times 1, or just 4. And at r equals 8, the rate of change would be 4 times 8, which is 32. And then the other thing that we want to think about is the units of our derivative. And so it says if r is measured in inches and a is measured in square inches, what units would be appropriate for dA over dr? We talked about this before when we were talking about velocity. You just take the units of A over the units of R. Or just like if it was Y's over X's, you take the units of Y over the units of X. So A is measured in square inches. And R is measured in inches. But be really careful because being the math people that we are, we want to just say that that just cancels out to inches. Right? But we're talking about units of like what's changing, so you can't cancel that out. Like you say the units are 4 inches squared per inch. So what does that mean? It means as the radius changes, the area is changing so many square inches per inch. That the radius is changing. Read it. Square inches per. So there's a question or two on homework. Some of them give you the formula, some of them I just and I'll see on Monday. But on Tuesday we can finish the rest of the know how to do derivatives, we're going to get into a lot of more stuff. Just say my derivative, and if it works out, we're going to figure out correct